Welcome to the unit on transformations. In geometry, a change in the position, size, or shape of a figure is called a transformation. In this unit, you'll learn about transformations and how to apply them to the real world. Geometry includes the study of movements of figures. If you move all the points of a figure according to a set of rules, you can create new geometric figures. There is a correspondence between the points of the original figure and the points of the new one. The pre-image is the original figure. Image, the image after a set of rules have been used. Isometry, a transformation that preserves size and shape, also called a rigid transformation. The first type we'll be focusing on are called translations. Translation, it's the most simplest type of isometry. Take an image and essentially sliding it without turning it or flipping it. All the points of the original figures are equal distance to the corresponding points of the image. Some people call translations slides. We're going to slide it to the left or slide it up and over. Here we have a musical note and it was translated to the right, or we slid it over. Right appear to be a isometry or a rigid motion. A rigid motion preserves both distance and angle measure. In this transformation, the distance between the vertices of the image are the same as the corresponding distances in the pre-image. Here's the pre-image, ABCD, quadrilateral ABCD, and let's look at the distance between A and D. 1, 2, 3. And here is the image. This is after the translation, which is 7 units to the left and 3 down. So we slid it over and slid it down. If we look at the distance from A to D is 1, 2, 3. The original vertices we call A. This is the pre-image. The image is A prime. The little marking, we call that prime. Look at the angle. If you look at line AB, has a slope of 0. Look at line AD, has a slope of undefined, which means these are perpendicular 90-degree angles. Same thing here, we got a 90-degree angles. And we can go and check all the angles, and you'll notice that all the angles will have the same measurements also. So this is a rigid motion. It preserves distances and it preserves all the angle measurements. Example 1. Here's the rule that tells us on translation, on how to map the translation. In this rule it says take each X and Y coordinate of the pre-image, and we are going to take X coordinate, subtract 1, and we're going to take the Y coordinate and add 4. Which means we're going to move to the left 1 and we're going to go up 4. So here's point A of my pre-image. Coordinates is 3, 0. So if we take 3 and subtract 1, we'll get 2. And the Y coordinate is 0, and 0 plus 4 is 4. And so it's going to map me at 2, 4. Or technically, we're going to go back 1 and up 1, 2, 3, 4. And we'll repeat that for each vertices, A, B, and C. And so here we have a isometry or a translation, which takes the pre-image and we're going to move it to the left 1 and up 4. Here's a translation rule. It says the translation rule is take each coordinate and we are going to move it to the left 5 and we are going to go up 3. And here it's asking me what the pre-image is, and I notice the notation. This is A prime. This is the vertices after it's been moved, so I need to know what the original is. And so what I'll do is take X minus 5 equals 6. So X is 11. So my original coordinate was 11. And then I'm going to take Y plus 3. And when I moved it to the 3, I ended up at 2. So Y is negative 1. And so my original coordinate for A was 11 and -1. Here they want me to write a rule. I got quadrilateral ABCD, and it looks like it's got translated over and down, so I need to write the rule. So the rule would be, I want to take XY, and we're going to take all the X's, X coordinates, 1, 2, 3. We're going to go to the left 3, and we're going to go down 1, 2, 3, 4. So the rule is we're going to map XY to X minus 3 and Y minus 4. I guess you're ready for the practice now. Good luck, and bring questions to class.